Okay. So let's calculate. In our previous video, we saw a calculation across the resistors using obviously our circuit reduction method, right? And we reduce the circuit, calculate I, and then we we simply calculate voltage across R1 through our current calculation of voltage across R2. What we're going to do is we're going to solve the circuit again, okay? The same good VR1 and VR2, but we're going to use what we call voltage divider, okay? And we're going to show you how this works. So there's an equation you have to know, and I would put this on your cheat sheet. The equation is, right, VR1 here is our source plus the total resistance across this area. So here we go. So the equation is I want my voltage across VR1. Why? We're going to assume our current direction this way, okay, because it's going from minus to positive. Here's our current direction. That's our VR1. Okay, and we're going to drop VR2 this way. Okay. So we can write VR1 equal to Vs, and it's going to be over our total. So it's R1 over our total. Okay, so that's R1 plus R2. Now, if this was 3 resistors, it would be R1 plus R2 and R3. If it was 4 resistors, R1 plus R2 plus R3 plus R4. Okay, but since we have 2, this is our total resistance. You'll see it's 10, or 10 plus 10 plus 5. 10 over 15. VR1 equals 10 times 10 divided by 15. VR2 is going to be what? VR2 is going to be Vs, but it's now R2, right? So R2 is on the top, R1 plus R2 is on the bottom, so we can say it's 10, 5, 10 plus 5. Okay, where do we get our values? We got our values from up here. Right, we should be able to be good at plugging in values, okay? And 10 times 5 divided by 15 is 3.33 volts, okay? As we can see that from our previous calculations, right, that this and this 6.7 plus 3.33 is equal to 10. We can see here that this is also very similar. We got the similar answers, maybe a few hundredths of a decimal off, but we're close. We have 6.7 volts for VR1, 6.7 volts for VR1, and we had previously 3.35, which is very close to 3.33, so we can accept it, right? And this is the second method. So our voltage divider is the second method we use. Okay?